We talked about the conservation of energy. And one of the wonderful things to look at with conservation is a pendulum. And so today we're going to talk about a pendulum and we're going to do a lab on pendulums. So, pendulums are very simply some kind of object that's hanging that swings back and forth. Okay. And they've been around for a long time and they're used to measure time and the use of them to record time was something Galileo worked on in the early 1600s, and it wasn't until the 1750s that we actually had a working pendulum that could be used to measure time. And pendulums have even been used to show that the Earth is rotating, and so lots of use of a pendulum. So let's take a look. So what I'm hoping in this experiment you're going to be able to do is try to figure out what types of variables will influence the swing of a pendulum. So, a couple things. First of all, with a pendulum, got a long string there. With your pendulum, we don't want to start way up here, okay? Because here at 90 degrees, it's basically free falling at the start and it's going to cause some problems. So typically when we're doing pendulums, we're going to start no more than 15 degrees from the horizontal. So maximum of 15 degrees, okay? This works ideally if we had a frictionless and weightless string, but obviously that's not going to happen. And so I need to have a significant weight here so that the influence of my string here isn't affected. So what I can do is I can take this little hook here and I can put some weights on it to use that. So I'm going to put this one on. This one's 100 grams. I'm going to put 100 grams, and the ring itself is another 50. So I've got 150 grams of mass. And we are going to hang that from our string, okay? And we're going to try to go close to a meter in length. Now, mine's not a meter. I've got about half a meter here. And what we're going to do is we're going to start it over. Remember, not beyond 15 degrees. And we're going to let it swing. It's going to go over and back. We'll call that once. Over and back is once. And it's going to go. And what we're going to do is we're going to time it for 10 times. So with your partner, what you're going to do is you're going to put some mass here. Let's start with 150 grams. And your partner can use their stopwatch on their phone. So I've got my phone. And ready, set, go. And you are going to record how long it takes to do 10 of those. When it hits 10, stop. We'll record the time into a data sheet. We'll record the length. We need to know the length from where my fingers are to where the weight is. So I need the length. I need the number of oscillations. I need to know the time, and I need to know the mass. Okay? And what we should do is we should probably repeat that a couple times just to make sure we did it correctly. So make sure I don't move my fingers, make sure I've still got the mass on there. And I'm going to do a second trial. We're going to do 3 trials, and we'll use the average of each of the trials. So let's say the first trial I do it, let's say it takes 30 seconds to go 10 times, so they're 3 seconds each. I do it a second time, and maybe this time it takes 29 seconds, so that's 2.9 seconds each. Okay, and we can do it. So now what we're going to do is we're going to change the mass. So I'm going to keep the same length, but this time I'll put a bigger mass on there. So this time I've got 250 instead of 150 grams. Okay, so if I increase the mass, start at the same place, do everything the same, I want you to make a prediction of how this will change. How will this increase of mass change the time it takes to do 10 oscillations? Okay, so what we're going to do, we're going to do it once at 1 mass. So the first one I did was 150. Now I'm doing it 250. I'm going to do it again. Maybe I'll do another one. Remember, 3 trials each time. So 3 trials of 10 oscillations, same length. Everything's the same. I'm just changing the mass. Keep everything the same, just changing the mass. So now I got 350. How does that change how long it takes? Will it go faster? Will it go slower to do my 10? Do 3 trials. So now you've done your 3 trials at 150. You've done your 3 trials at 250. You've done your 3 trials at 350, or whatever mass you've chosen. So think about it and look at your data, do some calculations, and say, okay, how did changing the mass influence my pendulum? Okay. Now we're going to look at variable number two. Variable number two. Okay. We started hopefully at the same place every time in around 15 degrees. What would happen if I started at 5 degrees? Okay. So once again, the first couple times you did it, you started here. Now I'm going to try and just change this. So what I'll do is I'm going to go back to my 150. And if I have 150 grams, keep the length the same length, but just decrease where I start from. How does that change the time it takes? All right, now for your third variable. So this time what we're going to do is we're going to keep the mass the same at 150. We're going to go back to starting at the same place in around our 15 degrees, but we're going to shorten the length of the string by half. So if you had a meter, so you've measured the previous one, let's say the previous one was 108 centimeters. Just let's say that's what you had. If you had 108, I want you to go to 54. I want you to cut in half your length. So, mine, I had that. So my length cut in half will be right there. So there's my length. How is that going to impact upon the time it takes to do my 10 oscillations? Once again, 3 trials on everything so that we can get good data and we can verify that we've got good data. So we're going to do 10 times, take the average, and then what we'll do is we will do 3 trials, average the average.